Hey guys, welcome to the review of completing the square. So this will be page 10 of your packet, and we're only going to do the first two examples today and then save the next two for tomorrow. So before we begin, this is review, so we have done this before, but I do want to write down the steps because it is a process that doesn't necessarily come naturally. So we're going to find the roots. And if you remember from before, roots are where the quadratic crosses the x-axis. So these two spots where the graph would cross the x-axis would be the roots. So the first step that you're going to do is to isolate the x terms from the non-x terms. And what that means is that anything with an x needs to be on one side. I typically like to keep it on the left, all the x's. And anything that does not have an x attached to it would have to move over to the right-hand side of the equation. Now, in step one, in the same step, you are also going to find what I call the three b's. So that would be regular b, which b is always that number that's in front of the x term. Then you're going to take b and divide it by 2, and then you're going to take b over 2 and square it. So b over 2 squared. So an example would be like if b was 6, then b over 2 would be 3. And b over 2 squared would turn into 9 because b over 2 is 3 and 3 squared is 9. So something like that is what you're going to have to do in step 1. Now for step 2 we are going to add the b over 2 squared term to both sides of the equation. So I can handwrite this. We are going to add the b over 2 squared term to both sides of the equation. Now for step 3, there is a trick in step 3, so you can skip to how to factor it. So you're going to factor the left side of the equation as, and this is the trick, it's always going to work, x plus your b over 2 value, the whole thing squared. So for instance, in that original example where I said 3 was b over 2, I would replace the b over 2 in this parenthesis with 3. So I would have x plus 3, the whole thing squared. Now, if you don't like this shortcut when we go and do an example, I can show you a little longer way of doing it that might make more sense. But for now, just keep that in as your steps. And we're on to step 4. So in step 4, we have to take the square root, so I'll just do the symbol for the square root both sides of the equation, and the last step that we're going to do is to simply solve for, and I'm going to write x values because it's more than one, so you're going to find 2 x terms here, not just one. And a big important piece that a lot of people tend to forget is that you need to remember the plus or minus. Now, if you forget the plus or minus, you're only going to end up with one x value, and that's how you should be able to tell yourself that this probably isn't right because 99% of the time, we're going to end up with 2 answers, 2 x values. So if you need more time to copy down the steps, pause the video now before I go into our first example. Okay, so our first example already has half of the first step done because the x terms are already isolated. You'll notice that your x's are on the left and the non-x values are on the right. So what we have to do next is figure out what's b over 2, and what is b over 2 squared. And I always just do this off to the side, just so I don't interrupt the work that's going on. Now, b is always the value that is in front of your x term. So in this case, your b value is -18, and that negative does make a difference. To find b over 2, you're going to take that -18, plug it in for b here, and when you divide -18 by 2, you're going to get -9. Then, to find b over 2 squared, you're going to take that -9, replace it with b over 2, square it, and you'll end up with a +81. Now, your squared terms are always going to be positive. Now, if we look at our steps, step 2 says to add the b over 2 squared value, so this 81, to both sides of the equation. So I left a little space here so that hopefully you can squeeze in plus 81 on both sides of the equation. Now we're on to step 3, where you factor. Now I'm going to show you the longer version just once here. If you only look at the left side of the equation, right, x squared minus 18x plus 81, you're asking yourself, what are factors of 81 that add up to -18? And hopefully you would eventually figure out that -9 and -9 would work. So from your factoring days, which we reviewed last week, hopefully you remember that it would turn into x minus 9 times x minus 9. And then when we simplify what's on the right-hand side of the equation, that turns into 121. Now, the shortcut would essentially not include this step. So I'm not going to cross it out, but in the future we don't have to write it if you understand that in the shortcut you can just write down x minus 9 squared, because it's the same thing as writing x minus 9 times x minus 9. And if you're wondering how you know what to put in the parentheses, looking at step 3, it says to always use your b over 2 value. So that -9 is going to be in the parenthesis. Now we still have it equals 121. And we're already on step 4. Step 4 tells us to take the square root of both sides. So take the square root of both sides, and what we're left with is, now square roots and squares cancel each other out, so you're just left with x minus 9. And here's the part that you don't want to forget. The square root of 121 is plus or minus 11. That plus or minus is key in allowing us to find both of our x values for answers. Now, all we have to do is solve. So to solve here, in order to get x alone, the opposite of subtracting 9 would be to add 9 to both sides of the equation. And if you're unsure of how to work with this plus or minus, what I would suggest doing is breaking it up into 2 equations. So one equation would be that positive 9 plus 11, and the other equation that you have to work with is that positive 9 minus 11. Now when you simplify this, 9 plus 11 would give you an x equals 20 answer, or the other option 9 minus 11 would give you an answer of x equals -2. And thus we have our final answers of what our roots are. So this specific parabola will cross the x-axis at -2 and +20. Obviously this is just a really messy sketch, but you get the idea. Okay, if you need to pause the video now to copy down anything, go ahead, and I'm going to move on to our last example for today, example 2. Okay, example 2. Example 2 does not have the x terms isolated quite yet. So that's what we're going to do first. We are going to add 51 to both sides of the equation so that our x terms are on the left and our non-x terms are on the right. Now, I like to give myself a decent amount of space, mainly because I write so big half the time, but that's just so I can add in for my next step the b/2² term, and I don't have to rewrite it. So, off to the side, we're going to find what b is, what b/2 is, and what b/2² is. Always have to start with b, and b is the number that is in front of x. So in this scenario, b is 14. Now b/2 would take that 14 and divide it by 2 to give me 7. And b/2² would take that 7, square it, and give me a +49. Now, the term that we add to both sides of the equation is always the b/2² term. So that +49 is going to fill in adding on both sides of our equation. And now we're on to step 3. Now remember, step 3 says to factor the left side of the equation as x plus b/2, the whole thing squared. Now what that means is we're going to take x plus, we're going to use our b/2 value to replace inside of the parentheses, and that whole thing is going to be squared. Equals, when we combine 51 and 49, we end up with 100. And now we're on to step 4. Step 4 says to take the square root of both sides of the equation. So, take the square root of the left, take the square root of the right. Squaring something and square rooting something are inverse operations of each other, which means that they cancel each other out. They're opposites. So, what happens on the left is the square root and square cancel, and we're just left with what's inside, x plus 7. Now what happens on the right will always happen. We always get this plus or minus, and when we take the square root of 100, we end up with 10. Now we're on to the last step, which says to simply solve for x. So, to solve for x, I need to move that +7 by subtracting 7 from both sides, and I'm going to end up with x equals -7 plus 10 as one option, or x equals -7 minus 10 as the other option. Remember that plus or minus is attached to the 10, which is why one version is adding it and the other version is subtracting it. When I simplify this, I will end up with -7 plus 10 is a +3, or my other x answer, -7 minus 10, is a -17. So, My final answers are x equals 3 or x equals negative 17. Those are the roots of this particular quadratic. And again, that's where we're going to stop today, and I'm going to finish these notes, questions 3 and 4, tomorrow so that it's not so overwhelming.